back to the presentation. So delivering broadband services cost effectively. So we're going to have Bodil go ahead and review some of the different types of broadband services out there available, and then show you how Omnitron fits into this picture here.
Thanks, Jake.
Bodil,
so typically when we talk about broadband services and access segments of the network, we talk about business Ethernet services, some of the rural telcos, and also in densely populated locations, we are starting to see more fixed wireless deployments. Our products can also be used for mobile backhaul. That's also a different type of service. And we also could potentially use some of the products for residential broadband services. Next slide, Jay. So typically where Omnitron's products fit in the network, our area of focus is primarily on the customer premise equipment and in the access portion of the network. They've been in the industry for a really long time, and we've decided to focus on that segment of the network. So typically our products would be deployed at the customer premise location. Some of our first level aggregation devices could be deployed at the central office or the head end of the access network. You could also use our products for mobile backhaul, front haul, CPRI type of applications. We're starting to see some of our products being used in small cell deployments, especially our Power over Ethernet portfolio. We do support extended operating temperature, so you could use our products in NEMA enclosures. Our iConverter platform is also used in a lot of data centers in the meet-me rooms to provide different types of fiber to copper conversion and transponder type of functionalities. Distributed antenna systems could also be used along with our CWDM products to be able to multiplex multiple services and service provider traffic to head back to a central location. We also have multiple ring type services protection capabilities that we'll talk about when we move forward. So what exactly is a NID? So basically, NID is a network interface device. It's also called a demarcation device. And what it is, it's basically a demarcation between the service provider segment of the network and the user network. So the reason the NID is important is when the service provider provides a particular service to an end customer, they need a way to be able to test their portion of the network in case there's any failures or if there's any performance degradation. So the demarcation device is the one that the service provider would connect to perform a loopback test or to perform a throughput test to ensure that their segment of the network is functioning fine and help troubleshoot the customer's service. So when we talk about NIDs, that's the type of device we're talking about, is the actual demarcation device. Moving on to the next slide, Jake.
Yeah, real quick, I'm going to just also launch a poll too, so we can stay interactive with our visitors here. If anyone's currently using NIDs in their network for demarcation. All right, Bodil, go ahead. We'll go ahead and continue now.
Sure. So Jake quickly mentioned the Metro Ethernet Forum in the previous slide. So the Metro Ethernet Forum has defined at a high level 4 different types of services for Ethernet services. E-line is typically used for point-to-point type of applications. E-LAN is the most typical type of deployment, which is for multi-point to multi-point communication or a campus network. E3 is more of an IP TV multicast service type of application where you're doing multicast services. And E-access provides a standardized way to interconnect between multiple service providers and have a defined handoff between these services. So all of the products that we talked about today, especially the GM4 and XM5 NIDs from the Omnitron portfolio, are MEFC 2.0 certified for all 4 service types: E-line, E-LAN, E3, and E-access. So let's talk about how business Ethernet services are typically provided in the industry. So most access segments are built out using protected 10 gig rings. In this example, we're showing you how you could build out protected 10 gig rings using a combination of our XM5 10 gig NID as well as our XM5 aggregation devices. And as and when you need to start handing off services to different customers, it could be businesses, it could be multi-dwelling units, or schools or hospitals, you could install our 1 gig or 10 gig NIDs at those customer premise locations and aggregate all the traffic onto your backbone ring. We could also provide some power over Ethernet type of services. So if you have security cameras or Wi-Fi access points that you need to power, we have a wide portfolio of PoE products that could be used to connect into the same access ring. So this is kind of a typical access ring application where you could use business Ethernet services could be provided with these types of rings. Now, a similar architecture could be used to also provide mobile backhaul services. Our products do support synchronous Ethernet and 1588 transparent clock, boundary clock, and slave clock. So these protocols are necessary when you're talking about timing and synchronization for mobile backhaul networks. So the concept is pretty much the same. You're building a core 10 gig access ring, and as in when you add more and more cell sites, you could use our 1 gig or 10 gig NIDs to provide the cell site connectivity and backhaul the traffic towards your core network. This slide shows you how you could use a combination of our carrier Ethernet product portfolio along with our PoE portfolio to provide small cell and Wi-Fi access point type of connectivity and services. So in this example, we're showing how our XM5 10 gig aggregation NID is being used as the distribution point or the first level aggregation point and providing connectivity to our 1 gig PoE NIDs that in turn are powering small cells. So again, a wide portfolio of products that can be used to complete an access network and provide different types of services.
All right, awesome. Thanks for those explanations on those applications, Bodhu. Now we'll go ahead and just kind of review some of the Omnitron NIDs here and show you some of the capabilities and features within this iConverter system. So Omnitron, we call this a multi-service platform, meaning that you could install different modules into the same chassis here that also have different network protocols. And so you can deliver different types of services all through this one chassis here of iConverter, media converters, as well as NIDs and CWDM multiplexers. So this chassis, again, will accept both plug-in cards, or the iConverters can come in their own standalone form factor configuration here. But the nice part about Omnitron's system here, it's nice and flexible. And so you can reuse a lot of these same plug-in cards within various areas of your network as you're looking to turn on more services for new customers. And here's a nice look at the iConverter product types used quite frequently by the telecom folks. And so our network interface devices, as Bodhu mentioned, the GM4 and XM5, these are Carrier Ethernet 2.0 certified for demarcation devices. These come in either the fast Ethernet 100 meg gigabit or 10 gig data rate speeds. And Omnitron has a nice tiered product offering to match the different types of services that a service provider can offer. Also with our CWDM multiplexers, which you see here, these are great devices for expanding your fiber capacity over your existing or new fiber lines. So instead of just sending one channel of data over that fiber, you can send up to 16 different channels over that same fiber with CWDM technology. So Omnitron has a nice variety of multiplexers, demultiplexers, and also the add and drop optical multiplexers for dropping off wavelengths to customers along the way. These can also be used in both dual fiber, single fiber, or with multi-mode fiber as well. Omnitron also does have T1 and E1 multiplexers too. So if you are still offering any T1 services to your customer and need to save on fiber by multiplexing, we have a nice flexible offering there for T1 muxes as well. And now I'll kick it back over to Bodhu so he can kind of walk you through the different iConverter NIDs that we have available.
Thanks, Jake. Yeah, so when we developed the NID platform, we decided to come up with a tiered NID offering. As you can imagine, not every service provider has the same requirement and same price point when it comes to a demarcation device. So at the lowest end, we have our M2 NID. This is best for best effort type of traffic, point-to-point type of connectivity. And for end customers that aren't necessarily your premium customers, you just want to be able to provide a managed service that you could connect and troubleshoot remotely, but they're not necessarily looking for the latest SLA capabilities and protection capabilities. As we move up the food chain, that's where our premium CE 2.0 certified NIDs come into play, the GM4 and XM5 NIDs. So these would be more for your premium customers, assured Ethernet services where they're paying you money to make sure that you're meeting an SLA and you also have the latest protection capabilities. So again, we have different price points and different functionality depending on the service provider and the end customer needs. Next slide.
Great explanation of that. Okay,
Right.
here's a.
This is just another representation of the same concept. Basically, we have a cost versus feature comparison. So as you can see from the chart, we have low cost, low functionality models that would be our M2 NIDs. And as we move up, we have the higher cost CE 2.0 certified NIDs that are full featured and have the latest SLA and protection capabilities. Those would be our GM4 and XM5 NIDs. We are known for our small form factor and low power consumption. Literally all of our NIDs fit in the palm of our hand. So, you know, it saves you cost in terms of the long run when you look at the power consumption. All of our NIDs are very compact, and that's one of the highlights of Omnitron products is the low form factor, small form factor and low power consumption. Some of the key features that we have with our premium NIDs is they support RFC 2544 and 1564 service activation testing. We do support both responder and initiator functions on our NIDs. These protocols are used when you need to turn up a particular service for a customer and you want to make sure that there's sufficient bandwidth within your network to be able to meet the SLAs. So before you hand over the customer service, you can run an RFC test or a 1564 test and prove to their end customer that yes, indeed, the network does have the capacity to meet the bandwidth requirements that you're promising to the end customer. We also support standards-based performance monitoring and fault management capabilities. So this allows you to proactively monitor the health of your network, and you can even set threshold crossing alarms in case you want to detect service degradation, errored seconds, or if there's delay variation in your network. You could set threshold crossing alarms for those. So it gives you the ability to proactively monitor the health of your network and react to service degradation before it actually starts to impact your end customer services. We also have the latest protection capabilities that typically you would expect in carrier-grade products. We support link aggregation, both active-active and active standby lag. We support 8031 and 8032, linear and ring protection. So with using these protocol protection capabilities, you'll be able to provide sub 50 millisecond switchover time in case there's a cut in the fiber or if there's a failure at one of the nodes. Next slide, Jake.
Yeah.
So if we look at the most basic application with our M2 NIDs, as I was mentioning, the M2 NIDs are primarily used for point-to-point type of applications. So in this example, we're showing you a typical potential campus type of network where you have a central location with our 19-module chassis, and then you have multiple remote buildings where you have our M2 remote units installed. This does allow remote management using our NMM2 management module. So at the remote buildings, all we're really doing is providing copper to fiber conversion, but we also have some basic traffic management and performance monitoring type of capability with the M2 NID. So this is a typical distribution network. As we move up to the M3 NIDs, you're not only limited to point-to-point connections, you can also do multi-point to multi-point or ELAN type of connectivity. So if you need to build out a campus network and you need to make sure that you have connectivity between all the different locations, the M3 NIDs would be perfect for those types of applications. One product I want to spend a little bit of time on is our SFP NID. What this is basically all the features and capabilities that you normally would expect from a NID, but shrunken down to an SFP form factor. So literally, it looks exactly like a normal SFP, but this device is a managed device. It's got its own IP address. It's got FPGA built into the traffic generation. So this becomes a demarcation point for service providers that are looking to save space and also looking to save an additional power run when they need to install an actual network interface device. Most of our SFP NID models are MSA compliant. We consume less than 1.5 watts of power, so you can install them in a lot of legacy devices without having concern about excess power consumption and potential heating issues. We do support initiator and reflector functions for RFC 2544, 1564, and TWAMP. This is unique in the industry. A lot of other competitors only support a reflector function. You have a lot more flexibility with our SFP NIDs because you could use 2 of them at either end of the circuit, and you have all the equipment that you need to do an end-to-end service activation or end-to-end performance monitoring using our products. Next slide. So a typical application for the SFP NID, as I was mentioning, would be in locations where you, number one, perhaps do not have space for a physical NID, or you don't have the ability to run an additional power line. So in this example, we're showing you how our SFP NID could be installed into a small cell. It could be installed into a cell site router. It could be installed into a customer premise equipment at a business location. So anytime the service provider needs to troubleshoot their network, the SFP NID becomes the demarcation point. They could connect to it remotely. They could do layer 2 VLAN loopback tests at the hardware level. They could do a throughput test, or they could even do the 1731 type of tests to determine where the fault is. So all the functions you normally would expect from a NID, but in an SFP form factor. So very flexible and a nice device to have when you're running low on space in your remote locations, and also when you don't have power. One other capability that the SFP NID offers is to pay-as-you-grow type of service. So typically when you're selling service to an end customer, you may start them off with an unmanaged media converter. They may not be a premium customer. They may just be looking for the lowest cost option. So you could sell them our small My converter, which would be the copper to fiber converter, which is unmanaged. As time goes on, if that customer sees a need for a managed service and wants to look at performance monitoring and SLA capability, all you really need to do is purchase the SFP NID, plug it into the My converter, and now that you can start offering managed Ethernet services with remote fault management, performance monitoring type of capabilities. So you could start the customer off with a low-cost solution with the unmanaged media converter, and as and when you need to add remote monitoring capabilities and SLA capabilities, you could just plug all the SFP NID in and add the latest layer to SLA capabilities. Another unique aspect about our SFP NID is what we like to call the fiberless SLA. So in this example, we're showing you a layer 2 legacy switch that does not have any SLA capability. So the service provider is not able to charge a premium for these services because they don't have any remote performance monitoring capability. They don't have any remote troubleshooting capability. So the way to solve this problem is to plug our SFP NID into one of the open SFP slots. You do not need to power the fiber side, just the electrical portion of the SFP NID links up. And now you could map those 2 services over to the SFP NID, and you'll be able to add remote troubleshooting, remote monitoring, and remote traffic testing capability. So you'll be able to provide assured Ethernet services while still protecting your install base of the legacy equipment. You may have paid a lot of money for that legacy switch, so rather than having to do a forklift upgrade for a newer device, you could protect that investment and provide the latest SLA capabilities just by installing our SFP NID.
Yeah, that's a great
Next slide,
feature,
Jake.
just to be able to add that management capability.
Correct, correct. Another important feature that most of our NIDs support is what we call zero-touch provisioning. So what this allows the service providers to do is to speed up the actual deployment and service initiation process, and it also reduces the expertise that's required by the technician that goes on to the remote site. So the way the zero-touch provisioning feature works is the services are pre-configured by the central location at the network operation center, and when the device is sent over to the remote location, the technician, all they have to do is plug in the NIDs, power them up, and connect the copper and fiber ports, and the configuration and the IP address is directly downloaded from the central location. There's no manual intervention required by the technician, and all they have to do is wait for, once the configuration is complete, the LEDs turn green, the service is configured, and the technician moves on to the next install site. So you don't have to worry about any security risks by providing user access information to the technician. You don't have to worry about training these technicians to be able to log into these devices and have to configure the services manually. It adds an additional layer of protection, and it also reduces the expertise that's required by your technician. So a very nice feature to have for the service providers to speed up the turn up of services for their customers.
Yeah, definitely another nice cost-effective way to get those services turned up quickly and saving time and money as far as the technicians are concerned.
Yeah.
All right, great. Well, thanks for the NID overview. We're going to switch gears real quick and review some of the CWDM capabilities and how you can increase fiber capacity using CWDM and DWDM multiplexers. So again, these are devices that can be installed into an iConverter chassis, or we also have passive chassis specifically for some of our CWDM multiplexers. And these are great for maximizing bandwidth on your existing fiber or even new fiber lines. So with DWDM, you can multiplex or combine up to 16 separate channels on that same fiber cable, and with DWDM up to 24 separate channels on that same fiber cable. So this is great as far as saving money for decreasing your fiber costs. So whether you're, again, pulling your own new fiber or trenching fiber and have to deliver new fiber to customers, or if you're perhaps leasing fiber from another wholesale service provider out there, this is a great way to decrease those fiber costs. Also, the nice part about the CWDM multiplexers is there's no power required. They're completely passive devices that act as light filters for the various wavelengths of data. And so there's no power required. So again, no additional costs there as far as powering this equipment goes. And they're also protocol transparent, meaning that you can feed different network protocols into the same multiplexer and send different protocols over that same fiber. So you can send Ethernet, T1, serial, CIPRI protocols all over that same exact fiber line. So taking a look at a few different applications using CWDM, in this case for mobile backhaul, and sending data from a central office out to the various cell towers here. So what we're doing is using a few different 8-channel MUX cards or multiplexer plug-in cards into our iConverter chassis and sending all 8 channels over a single fiber line out to these cell towers. And then we use what's called an add-drop MUX to drop off and add different wavelengths at each cell site location here. So again, a great way, instead of doing dedicated fiber to every cell tower, you can just do some multiplexing and drop off wavelengths along the way. Another nice way of looking at CWDM from a service provider perspective and saving on costs is to be able to deliver more services over your existing fiber to your end subscribers. So another application here showing our CWDM multiplexer cards all within this iConverter 19-slot chassis. So there's a few different CWDM MUX groupings installed there. And zooming in a little bit closer, you can see we have 2 different 8-channel MUX cards here, one with the upper band of wavelength and one with the lower band. And those are going to be all 16 channels multiplexed into what's called a band splitter. So those are going to combine both 8-channel MUXes into a 16-channel card and send all 16 channels over a common fiber link out to these subscribers or to these customers at corporate buildings. And then once all that data reaches that corporate building, it's a very simple way to demultiplex with the same part numbers here, same multiplexer cards. And we're going to demultiplex and convert them from a CWDM wavelength back into a standard wavelength that can be supported by some of these demarcation devices or NIDs here at the customer premise. So now running multi-mode fiber up the building to the various floors here and handing off services to these customers with some of the iConverter NID platform as well. So you can see it's a nice combination of using the CWDM MUXes as well as Omnitron's iConverter NIDs here to be able to deliver more services cost effectively over just that same common fiber line. So now we'll go ahead and switch gears one more time here and now take a look at some of the point to multi-point fixed wireless broadband applications out there using some of Omnitron's power over Ethernet equipment. Bodhu, do you want to take over on this slide here?
Sure. So just like with the NID products, we have a pretty wide portfolio of power over Ethernet products, all the way from unmanaged PoE media converters at the lowest end to enterprise-grade PoE switches, 8-port and 4-port PoE switches, managed and unmanaged, And we also have a wide portfolio of PoE extenders. What the PoE extenders allow you to do is to extend the reach beyond the 100-meter limitation that you normally have with the RJ45 interface. So one application specific to the broadband networks for the sake of today's discussion is the fixed wireless / point-to-multipoint type of services. So these types of services are required where it's not cost effective to install fiber. So typically in rural networks, you'll see these point-to-multipoint type of services deployed. And we're also starting to see these point-to-multipoint antennas being used in densely populated locations in the Middle East, where you have multi-dwelling units with a lot of subscribers, where it's not cost-effective to run fiber in these networks. It makes sense to install these point-to-multipoint radios. So looking at the network architecture, in this example, we're showing our RuggedNet PoE switch powering multiple point-to-multipoint head-end antennas. You typically have multiple antennas because most of these antennas have a 90-degree radius. So if you want to have 360-degree coverage, you need 4 or up to 8 antennas, depending on the spectrums that you're using. So at the head end, we're showing our RuggedNet PoE switch being utilized to power these antennas. And at the remote end, whether it's residential or a commercial building, you have the corresponding subscriber antennas that could be powered either using our media converters or an additional PoE switch. So this is a cost-effective way of providing point-to-multipoint type of services using these antennas, and Omnitron provides you the connectivity to provide power as well as data connectivity to these antennas. So again, this makes sense for locations where it's not economical to run fiber to these locations, or in densely populated areas like in some Middle Eastern countries. It makes sense to use these point-to-multipoint type of antennas.
Yeah, great description of this application here. Just to also add on to note that with the RuggedNet, these can provide up to 100 watts PoE per port to each of these devices. Same with the Omni Converter PoE switches here. So just depending on the radio you're using and how much power, or how power hungry that device is, Omnitron supports the latest standards, the 802.3 BT standard for the high power PoE as well.
In terms of the management, the Omni Converter and RuggedNet PoE switches do support web management. So all you have to do is punch in the IP address into any web browser, and you'll get this nice graphical user interface. And the RuggedNet picture that you see on the top is actually a live view. So you have a virtual view of what the remote product looks like, and the LEDs that you see on there are actually live. So if for some reason you have a loss of signal on one of those ports, those LEDs will turn green. This user interface also provides you the ability to take a status on the devices that are connected, how much power is being supplied to those devices. And if for some reason you need to perform a reset on one of the devices, or if you need to change the configuration, the GUI provides a nice, convenient way of performing those operations without actually having to become a master at the command line interface. So nice web management GUI for the Omni Converter and RuggedNet products for remote management.
Awesome, great. So now we'll go ahead and wrap it up and also review why it's cost effective to use Omnitron products. So right off the bat, Omnitron has a nice wide range of compact devices here, and the features that are going to match the types of services that the service provider needs to offer. So again, just depending on the type of services that you are offering, we have a specific NID that will fulfill those needs. And plus the nice flexible system within the iConverter platform makes it very easy to redeploy these devices. So if you're, again, switching these devices to a new customer and just want to rearrange these within the network, the nice flexible system allows you to snap these into various chassis and redeploy them wherever they're needed. There's also no need to forklift your existing equipment, so you can preserve your investment in that network infrastructure already and just use Omnitron as an add-on or a complementary product to what's already in your network. Another nice part about using Omnitron for our cost effectiveness is the ability to reduce your operating expenditures with the management capabilities. So again, like we showed you within the Omni Converter and RuggedNet management, the ability to save on truck rolls and technician time by doing remote power cycles to those PoE-powered devices, or minimizing the time it takes to turn on new services using the zero-touch provisioning features with our NIS as well. So those management capabilities really come into play and save customers quite a bit of money. Also, the ability to maximize the fiber capacity with CWDM. This is going to really help you save a lot of money on fiber costs. So whether, again, you're laying new fiber or having to lease that from another service provider, the ability to send up to 16 channels over that same common fiber will really decrease your fiber payments. And also with Omnitron, as I mentioned in the beginning, there's no service contracts. So Omnitron's always going to give you free support, both pre-sale and post-sale, to really diagnose, figure out, and find the right product for you. And then also after the fact, we have a great support team here to help you with anything that may come along the way. So there's no additional service contracts with Omnitron equipment too. So another quick summary and key takeaways from the presentation today. We know there's many and multiple options for delivering broadband, so we just want to help you be able to choose the way to do it most cost effectively. And that can be done by using Omnitron's compact NIS and demarcation devices, as well as our CWDM multiplexers to help you increase fiber capacity, and also our power over Ethernet switches, media converters, and extenders. These are great ways to power some of those point to multi-point antennas for doing the fixed wireless services. So anytime you're running across any applications that involve Ethernet, fiber, PoE, demarcation, CWDM, if you're hearing any of those buzzwords, please give Omnitron a call. Contact myself, Bodoo, reach out, and we can help review those applications with you, and then provide the Omnitron recommendations. Again, free network design consultation there. So I want to thank everyone again for your time today and for attending this webinar. We're going to also go ahead and stick around, open it up for questions and answers now, and launch another poll here too. But if you have any other questions too, want to contact us offline, you can reach us at info@omnitron-systems. And here's a look at our phone number.